So you're walking around one day with a shiny new air horn that you just picked up from the dollar store, and a guy comes along, he's like, hey, that sound is like super irritating, and you're like the most annoying person on the street now thanks to that air horn, and you're like, wow, that's awesome. And then a shady guy comes up to you and he's like, hey, word on the street is you have the capability to be incredibly, incredibly annoying. So you know what I want you to do? I want you to annoy this person, because I don't really like him, but at the same time I don't like hate him enough to want to hurt him. So like if you spend some time annoying him, I'll pay you per hour. And you're like, all right, that's not bad. So you do this for a while, and then another guy comes and he's like, dude, I've heard about how annoying you can be, and I would also like you to annoy someone with your air horn. So he shows you the picture, and you're like, wait a minute, I recognize that guy. That's the guy I'm already annoying. He's like, wait, I'll pay you a way better rate. Like I'll increase your pay depending on how long you work for me. And you're like, all right. So wait a minute. If I annoy this person and I get paid by both of these people, if I add those two graphs, that's like so much money right there. And you know what? You know what I can do with all that money? I can buy more air horns and then make even more money, and then that cycles back, and you just get infinite money. And you're like, yes. All right. So that little scenario there has to do with a different rule of derivatives. It's called the sum rule, and it's kind of describes what happens when you take the derivative of two functions and add them together. So let's take the example of you getting paid per hour to annoy somebody, and the first dude offers to pay like a set amount per hour, and so the function is going to look pretty linear. So let's say we get paid like $10 or something. Let's graph that and see what happens. Okay, so a pretty standard graph, and we know that the derivative of this function is going to be 10 because, the derivative of a linear function is simply its slope. Now the second person offers to pay an amount that differs depending on how many hours you work for him. And he says that the more hours you work for him, the better your rate will be every hour. And this let's say that the function is 3x squared. Okay, so we can use the power rule, and we know that the derivative of this function is 6x because the constant is multiplied, so it's just 3, and then the derivative of x squared is simply 2x. Multiply those two together and you get 6x. So what happens when both people pay us for doing the same work? Well, the earnings versus time functions, we just add them, so it's going to be 3x squared plus 10x. And how can we find the derivative of this new function? Well, first of all, let's just consider the derivative to be how much you get paid per hour, because that's what it is, right? The derivative in this case is equal to d earnings over d time worked. So earnings over time worked should get you your hourly pay. In function 2, you're paid $6x per hour, so it's a variable, and you're getting paid differently depending on how many hours you actually work. Well, the derivative of the third function should represent, the total amount you're getting paid per hour, right? Because if you're being paid from the two sources simultaneously, it makes sense that your hourly earnings would be added together. So therefore, we can say that the total pay is going to be 10 plus 6x dollars per hour. And this, of course, is going to be the derivative of the third function. And thus, we can say that the derivative of the new function is equal to the sum of the derivatives of the individual functions that added to make it. So in other words, the d of dx, the derivative of 10x plus 3x squared, is going to be equal to the derivatives of its individual terms added together. So the derivative of 10x plus the derivative of 3x squared, and we know that this is 10 plus 6x. And the general rule for this, for derivatives, the sum rule, says that the derivative of two things added together, a and b, is equal to the derivative of a with respect to x and the derivative of b with respect to x. So if we describe this in terms of functions, it says the derivative of f at x plus g at x is equal to the derivative of f at x plus the derivative at g of x. And this means when we're doing derivatives with complicated functions, we can actually separate out each term and differentiate them separately, and that makes life a lot easier. However, this doesn't hold for when the two functions are being multiplied or when the two functions are being composed together, only for sums and also differences. And knowing the power rule and the sum rule, and that the derivative of a constant is 0, we can now differentiate every polynomial function. So that's pretty awesome. All right, cheers.